in the next episode. In this video, you're going to learn about Q-Latin1 string and Q-string view. I will cover what are they and the use cases when you will most likely use them. Let's start with Q-Latin1 string. In the last episode, we discussed the Q-string class. And as you remember, it stores 16-bit Unicode characters. It means that every character inside Q-string takes us 2 bytes. Sometimes it is not bad, because our application may need it for language purposes. But in case we know that our string is also SC valid, we can save up memory using Q-Latin1 string. SC characters take only 1 byte, but we are allowed to use fewer symbols, of course. Let me show you an example from the documentation. Here we have this function. I already have it in my editor, and I execute it. So as you see, we create a variable of type QString with some type, then compare it, is it equals, and if yes, then we just qdebug true. And I also have to include qdebug header. And then we do the same, but with the Q-Latin1 string. Let's execute it, see what we have. As you see, the results are the same. But it is all about performance. In the first condition, we compare our string with the C-style literals, const char. These literals implicitly converted to QString before comparison. Meanwhile, in the second condition, we make a temporary Q-Latin1 string. This class is a lightweight read-only string wrapper for the USST Latin1 encoded string literal. Here it compares the Q-Latin1 string object directly to the QString without converting it. Comparison is faster because it avoids memory allocation and leverages optimized Latin1 to UTF-16 comparison routines. It means that just makes it faster. Let's take a look at another example. Suppose you want to log some data and make it efficient. I'm making username, action, and ID just as variables. Let me paste it in my editor. Here, we make it just as variables, but it could be read from any other sources, of course. So, then I want to concatenate it and just log it to the console. In the first case, each literal is implicitly converted to a temporary QString. This one, and so on. Then I call to convert it to a number. To convert number to a string. When we use Q-Latin1 string to wrap SC compatible literals, no memory is allocated, and we don't perform any UTF-16 conversion. But here, the concatenation involves memory allocation and UTF-16 conversion for each literal, each of them. In here, we don't do that. So it just makes it faster. And if you want to log large amounts of data and make it efficient, it is better to use this kind of logging system. So, as I said, in the first case, in this slower case, QString implicitly converts and allocates memory. And in the second case, no memory is allocated and it just works faster. To wrap up your knowledge, I made this table with the key differences between QString and Q-Latin1 string. Here you have everything I have talked about. So encoding support, QString supports UTF-16, meanwhile Q-Latin1 string SC. The memory usage 2 bytes per character, 1 byte per character. Performance is slower for SC strings and faster for SC strings because it uses it mainly, and here the QString is used for any other, I mean, all kinds of characters in all languages. It just have more symbols that it can store. and QString is making implicit conversion of literals. The next class we got here is QString view. QString view is a kind of manager for many strings. It references a contiguous portion of a UTF-16 string, but does not own it. So just as you see on this diagram, it can point on some portion of the string, but it not own it. So you can search here, you can extract some data, and that's all what you can do. But after you pass some string to QString view, care must be taken to ensure your string lives longer than QString view, and no references to deleted data are stored. Because as everything here, you should ensure the original string outlives the QString view and prevent dangling references. This means that if, for example, QString goes out of scope and deleted, then QString view should be also deleted, and it can't point on dangling pointers. And that is the thing that programmer should care about. The main use case for this class is as a function parameter type. Look at this example. Let's say we have a string in format key equals to some value, like this, and we want to make a function that helps us get this value. Earlier, we would do something like this you see right now. So let me copy and paste it to my editor. And let's also call it. And Qt6 extract key, and I don't know, key equals to 1, 2, 3, 4, 5. Fine, let's see if it works. It works, get 1, 2, 3, 4, 5. And because we don't want to make a string modifiable, I made it constant. And to prevent the string from being copied, we take only a reference to it. But see, here's a couple of problems. A function can accept only a few types of strings, only like this literal, and maybe if I QString str equals to, let's make the same, maybe now ABC, I can also pass it. But in case if I have something like, let's make the array of construct t, strc to new equals to, and let's put like key e equals 1, for example. If I want to pass something like this, I can do it. Of course, it's pointer. Yes. Pointer to this array of characters. And in case I want to call it with this, I can do it, because no mention function for call. I get error. And of course, finally, after testing everything, we have to delete it. Don't forget, if you make raw strings like I had done here. And also, it's the first problem that I showed you. And the second problem is that function returns a new QString, which involves allocation and copying of the substring. So here, let's break down what is happening inside our function. We get in this starting string, so in our case it's key equals to. QString literal is just a macro to make string on compile time. Then we check if our string that is provided is starting with the key equals to. And if yes, then we return with the help of method meet that gets a string from the starting point that we provide. In our case, it's the size of the start. It's 4 because we start from the 4 in this index, and then we continue to the end of the string, and we return it. And in this case, if we return a QString, then it involves allocation and copying of the substring, the substring we extracted. I want to show you how to deal with it and see that example. And this is another function that does the same thing, but with the Q string view. Let me copy and paste it. Here we have. I change name. It does pretty much the same thing, but only here it gets literal. It gets Unicode literal, then checks it starts with an return. And so the type that it has as parameter is QStringView, and return type is also QStringView. If I call it, for example, let's test the same things from the start. It's maybe 2, then 2, 2. And here we have to pass this Unicode literal. Then str2 also. And as you see, we can call whatever parameters pretty much we want, because now I will show you why. Let's call and see what we got. We have a problem. Oh, of course, yeah, because here I should, when I make this kind of string, we should pass the ending of it, so our code knows where the end is. And here we have everything correctly. So the parameter is not marked as const, but we can't modify it. As here, for example, I write str append. I even can't write something like this. And the same applies to the QString view. I can't write something like append or str, whatever method that modifies. There is just no. So we can modify it because QString view doesn't own a string. Also, we not mark it as a reference. So it can accept all compatible types of strings pretty much, as I showed you here. And it's the list of these compatible strings is bigger. And the function also returns a QString view, which is a lightweight view of the input string. So no new allocation or copying is performed. But of course, the color, in our case here, the color who calls method, who calls function like this, needs to manage the lifetime of the original string. And the QString view is invalid if the original string is destroyed or goes out of scope, as I showed you, as I said you previously. So also, we not mark it as a reference, but it is not copied, because QString view is just a reference by itself to the string. As I see here, I repeat it. Accept all QString view compatible strings, no memory allocation or copying. It just returns a lightweight view, and function can't modify the string and doesn't need to create a new string. And I think this is it for today. I hope you enjoyed today's episode and the presentation that I made. I think firstly, the history of my channel helped you understand the topic better. In the next episode, we will start exploring QML and finally make some GUI. So don't miss out. Bye. This video is an introduction to Qt6 and GUI programming with Qt. I will start by clarifying the difference between QML, Qt6 and Qt widgets, then I will explain why I chose Qt6 over the Qt widgets for this series, and finally, we will write a few lines of code in QML language so that you will see your first self-made GUI. In the last videos, we explored the basics of Qt, but only with the console up. From now on, I want to make examples in UI, so that as the series goes on, you practice the skills of making user interfaces with new tools. I just want you to use Qt core functionality together with Qt Quick. Let's start by answering the following question. What is QML? QML, by the way, it means Qt modeling language. is a declarative programming language designed to define user interfaces. Declarative means that it focuses on the goal, in this case describing what the UI should look like and how it behaves, rather than how the goal should be achieved. Uh, JavaScript is the subset of the language, so you can add logic and interactivity to your QML components. If you're familiar with JS, there won't be any problems with starting to write QML code. Let's explore an example of QML usage. The code consists of two key items, rectangle and text. Each item has its own set of properties inside, for example, width, height, text, etc. And here's how it looks like, you see. This example demonstrates how the structure of QML language looks like. And additionally, QML allows you to define signals and slots to integrate JS, adding interactivity and functionality. So as you see here, you have some items, for example, a rectangle. Well, you know what rectangle is, and have some properties, for example, width, height, color, and so on, so on. So it means the declarative language, like you declare what you want to see. QML language is used with Qt6. So what is that, and how are they related? Qt6 is the UI framework that powers QML. It provides a rich set of tools for building UIs, and it works nicely with embedded and mobile platforms also. Qt6 is easy to style, customize, and animate, and that's great. Look at the previous example, okay? As I said before, rectangle and text are items that help you build your UI. But these items are really coming from Qt6. And firstly, you should import Qt6 in your code in order to use them. The conclusion comes out of this is that QML is a module that provides engine and language infrastructure. Meanwhile, the Qt6 module provides all the basic types necessary for creating user interfaces with QML. With the help of Qt6 types, you can create and animate visual components, receive user input, and just build modern UI. See here, you have a bunch of items that you can add to your QML code. Think of QML and Qt6 like this. QML is the script you write to describe the UI. It's like HTML on web page or the blueprint, you know. And Qt6 is the library that provides the actual elements and functionality. It's like CSS and JS frameworks in web development, or just toolbox and materials. By the way, you can also create your own items. Technically, self-defined items were created using QML, but powered by Qt6. And it is also possible to make items using C++. And in most cases, it's a preferable option. And I will show you in more details about that in later episodes, so don't worry. And we'll make our components with QML, we'll make our items with C++, and you will see how it's done. And then it is also possible to integrate those items from C++, for example, or some data from C++ to the QML. And that is great. You can later use this in your Qt6 items. And now see, there are really two ways of building GUI in Qt. First is Qt6, and as you see here, examples of application made with those two ways. Qt6 is modern, customizable tool with many features, and it is better for big and custom projects. Meanwhile, Qt widgets, it's older, hard to customize, but the main advantage is that it comes with many items that look natively for the desktop platforms. So you don't need to write a lot of code to make your application look natively for all platforms, and you have many like components, many items to use inside. And now we have the third element of today's topic, Qt widgets. What is it? What is it? And why did I choose Qt Quick for the series? Qt widgets provides a set of UI elements to create classic desktop-style user interfaces. It is an older way to make GUIs on a desktop. Using this approach, we get plenty of controls that are adjusted to different platforms to look natively. Mostly, widgets are general, and many things have been already coded for you. But this approach also has such disadvantages as difficulty in styling and animating, its horrible looking widgets on mobile platforms, and less opportunities to make something unique rather than just classical looking application. When you develop applications with Qt widgets, you don't use anything like QML. The code is written in C++, and the visual part is done with the Qt widgets designer, which uses what you see is what you get, or simply receive approach. To summarize the difference between Qt Quick and Qt widgets, I have this table. So Qt Quick is easy and flexible in styling, rich and customizable animation, platforms embedded and mobile, and also desktop. Here, I mean, the embedded and mobile is possible. And language used is QML. Qt widgets are hard to style, it's limited in animation. Platforms, in most scenarios, you'll use it only on desktop. There probably, I mean, there are chances you can use it on embedded on mobile, but rather just on desktop. And language used is C++. And like understand it right, because in Qt Quick you like also use C++ to define something, but in Qt widgets like you make everything with also this structure that I showed you earlier in QML when you write some items. When you use Qt Quick, you separate your parts and you can create, for example, your items, some custom items in C++ and provide them in Qt Quick. But in Qt widgets, you make everything in C++. I will use Qt Quick in series because it is more modern and gives us more flexibility. Nowadays, most companies that are using or starting to use Qt prefer Qt Quick. Now let's create your first GUI app with Qt. As always, go ahead, click at Create Project, then select Qt Quick Application, because earlier you selected Qt Console, now Qt Quick Application. Choose, title it something, I'll name it Video, as always. Next, finish. You're going to see the default code generated for you in the QML. Delete this input panel because we don't want it right now. We now want something more simple. And you also can delete this import. And for this basic structure, it's just a window. And if you run the application, but sorry, now I increased the scale. If you run the application, you can see, now you'll see the window with a width of 640 pixels and height 480 pixels. And the title, Hello World. Everything you see is defined in your code. And that is the beauty of declarative language. And now let's quickly go through the project structure, because we have a slightly different configuration in CMake list from the previous one with the console app. And there is also a new code in the main to display UI. See here, you have some another stuff, and in main you also have some new code made for you. And I opened two projects. Is one from the previous tutorial. It's console app and our here. So I will just compare CMake lists file. In console app, for example, let's start here. We used to find a package here with the core, but in the new application here we also use it. We include finding package quick, but it implicitly includes the core module as well, and we don't need to find those two packages because it just implicitly imports also the core. If you take a look at documentation, here you see what modules we have. They're essential ones, so you see. For example, we have Qt Core, Qt QML, Qt Quick, Qt GUI, and so on. So let's add some comment so you remember. By the way, in CMake you make comments like this, like in Python. Implicitly includes the core module. And then there is also some unknown for us call to function Qt standard project setup. What it does, it's here, as you see the difference, here you have something like this to enable mock and to set some properties. And really what it does, it sets those all variables for us, and it also makes a couple of other configurations, so don't replace it with what you have in your console app. Don't replace it. I mean, it will work, but in the long term it will cause you some problems because it also configures some things related to files, and all this includes stuff. So it just helps to configure your project. Despite add Qt add executable, because here you have only Qt, only Qt, not Qt, but just add executable. Despite that, you also have a Qt add QML module. This command defines a QML module that can consist of, for example, C++ sources, QML files, media files, and many other stuff that we will use in later episodes. And then after you add it here, you can use it in your QML code. So if you want to drop some image in your code to make it visible in GUI, you probably gonna need to add it here with this command and then use it with QML. And then set target properties. Set some properties on a specified target to affect how it gets built on different platforms. So let's also comment affect how it gets built on different platforms. And for example, just you set something that is needed for macOS, for Windows, and so on. You can find in documentation what every property mean and how it affects the process of building different application for different platforms. I want to close it, okay, because I don't need this console app application from previous episode. And in main CPP, you also got this new chunk of code. And let's break down this step by step what is happening here. So firstly, the QML, also here you have inputs, of course, and QML application engine is used to load and manage QML components in your application. For example, as you made here. And it also, if you want to, I don't know, integrate some C++ code to QML, you will also need to use it, okay? And then we are setting up a signal slot connection for error handling. This signal here, object creation failed, is as you probably guess, emitted if the engine fails to create the root QML object. For example, due to missing files or errors in your QML code. We provide lambda in the slot. Here we have a lambda function that exits with the code -1 if creation is failed from the application, setting up a signal slot connection for error handling. And then we have engine load module and name of our project and main. Here we also have main QML file. And by the way, Qt connection is used for thread safety. We'll talk about it in later episodes about multi-threaded applications, but now just know that it used for thread safety. Let's also add it somewhere. It's used for thread safety. And finally, as I said, we have this loading. This method loads a QML module that was registered previously. Here we registered QML files, main QML, and now we can use it in this method. Method loads a QML module, name it tutorial 7 video, and searches for a QML file named the main QML within that module. If the main QML is found and successfully loaded, its root object becomes the main UI of the application. So, once QML module. We will now write a minimal app that displays a welcome message and a button. Clicking the button changes the message, this one, hello world, to something else. Of course, full code is in the GitHub repository, link in the description below. You can take a look or download or whatever. Let's go to the editor. First of all, let's go to main QML, change the identifier window to root because it is more convenient name for this element, and I also want to change this hello world to welcome app without this function we used before, QSTR. Because this function is used for internationalization, and for now it is not important for us because we write just simple application. Then let's make this text you saw on the top. I will just copy and paste and not take your time because in previous episodes I coded everything, live coded, but I think if I just paste small chunks of code, it would be faster and I won't just spend your time on my writing. So here what we have, text, just welcome to Qt Quick. I made the font bigger and provide pixel size 24. To locate the item on the window, we use anchors, these anchors. In this case, I am taking the horizontal center and the top position from the root and shifting text on 20 pixels to the bottom. So here, as a horizontal center, where its center of my element is text, I take parent, this means like this root, and the horizontal center from it. So my text will be at the horizontal center of the window. Then as the top, I also take parent top, so my text gonna be on the top of the window and on the center. And then I make this margin 20 pixels, so it is not just right on the top, but have some margin also. Let's see, save all. Let's see what how it looks like. And you see, as I said, horizontal center, top of the window, and small margin so it looks more beautiful. Fine. The next text item is the one that will be changed later. So I also added here an ID to it. Welcome message. We provide ID because later when button will be clicked, we're gonna change this. So we got to find this item. For example, here I used parent, but I can also use root. Okay, there's no problem. But when you can use parent. Okay, then text hello world default one. Make pixel size. I make font size a bit bigger, and I center it in the parent. As you see, I didn't use horizontal center or something. I just center in because we wanted to put on right on the center of our window. Here we have it. Fine. And the button on the bottom of the page is located similarly to the top text, but with the margin from the bottom. So let me copy and paste it just. Here we have rectangle. There is no really such thing as button here, so you just make rectangle. But it is easy to style, don't worry, it's not some cumbersome stuff. So here you have rectangle, and imagine that this is just a button. I'll show you how you can handle on click event. So width, yeah, I said set width, height, color, border radius, so our border is gonna be like rounded. Center it on horizontal, then put it to the bottom and make some margin from the bottom. If you take a look, I have this kind of button. Then I also want to add some text inside it. Of course, I can nest my items. And here text, click me, color, and center in parent. In this case, parent gonna be rectangle, not the window. Okay. I mean, if you are familiar with CSS and like with a little bit web development, it won't be any problem for you. And here we have click me, but if I click, nothing is happened. So I have to add event. Also inside a rectangle, add mouse area. Mouse area just helps us to make some events with the click. It can be on clicked, on hover, and someone will explore more later. Uncross fill parent, it just means that this item fills all the full rectangle. And on clicked, as you see, the code inside unclicked event is just JavaScript, and we just provide this method. I mean, not method, what we're making when someone clicks it. And on clicked, let's say if you got click me, if I click, you click the button, fine. And you can do something with on hover and so on. Just to show you that it is just JavaScript, I can write something like this. Console log click. And now look at the application output. If I click, here I also have a message from the QML, click. So console log just outputs it in our application output. As you see, it is not hard to implement this kind of application. It was pretty easy. I just used Qt Quick items, and you can build bigger and bigger applications. Okay, to wrap up your knowledge, QML and Qt Quick simplify modern UI development. Qt Quick offers flexibility and animations, and we'll explore, of course, more advanced features in upcoming episode. Okay, and I think this is it for today. Thanks you for watching, and I hope you like this introduction to QML and Qt6. So see you in the next episode. Thanks you for watching. In this video, I will show you all the possible ways to integrate your C++ code into QML. Then I will explain the pros and cons of every method. And finally, we will make this simple app using both C++ and QML that will filter and display logs in the file provided by the user. But what does integration gives to us? As developers, we always care about the performance and extensibility of our applications. QML and C++ integration gives us the ability to separate logic. So QML handles user interaction and the visual part, and C++ handles the logic. Uses data models and can call, for example, third-party libraries like Windows API. Now I will make a logs filter application and then show you all the ways to integrate it with C++. If you're not interested in coding UI and C++ class that will be later integrated and just want to see the just the integration part, go to the next section with the context properties, and you can get the full code for free from the GitHub repository link in the description below. Our application will read logs from that kind of text file where a type prepends a log message. For me, it was just ChatGPT generated. Here you have type of log for info, warning, error, and so on, and just the log that will be displayed. And our application will read that kind of file and display it and filter it and display only needed logs. I already created my project for today's episode, and now let's make a new class. As always, create new class and call it logs filter. It's gonna be like a backend for our UI. It must be QObject in case we want to integrate it with QML. You must specify it as QObject. Next, you know how to do it. Create your class, and in the header file we will have three properties: file path, filtered logs, and file name. The file name will be derived from the path, so I will only make a getter for it. And now let's just copy and paste so I don't spend your time. In the private section, let's make two QStrings. And so both stored properties are of type QString, but logs can be made with the QString list because it is just the list of logs. But I use string for the simplicity. Okay. And as I said, we're gonna have one more property as a Q property. I will show you later what it is with the file name. Because as you remember in our presentation, here no file chosen, then the file name will be displayed here and in this field. Qt provides us a property system for QObject to simplify a way of making properties with all needed things such as getters, setters, and etc. So all you can do is here add this macro provided by Qt. It makes property reactive, so it will call. So QML will call getter every time value gets changed, and make data valid in UI. You'll see more clearly why we use it when we will integrate this code with QML. But for now, as you see, here we can specify in EAQ property just our property, then access point to read it, to write. It's like it's gonna be just getter and setter, and notify is just a signal when this property is changed. So it's just, for example, if I will expose this property in my QML and in C++ emit this signal, then it will automatically be changed. So my getter will automatically be called after I change my property, and I don't have to bind my signal to some slot to call every time some getter. Everything QML makes everything for us, and when we will make UI, you will see more clearly with the example what I mean. Despite the thing that Q property gives us auto signal notifications, as I said, if it means that when we emit a signal in a notify, the property will automatically update it in QML. It also gives us meta object support and simply readability. It's just conventional to register properties like this in Qt. And now we should define everything needed for properties. So let's start with the get file name. It will be getter for our file name here. I make it const because value returned is constant, and we don't change anything inside our method. Then we need to make getters for filtered logs and file paths. As you see, names are the same, but this is getter, this is method. And I just return my property m filtered logs and m file name. By the way, m means member. If you never heard of it, m means member. And then setter for the file path, and notice that file path is the only property that has setter inside. So we set some new file path, and in the signals we make 3 signals for each property we have, and then we will emit it. For example, in the file path setter, we're gonna emit file path changed and file name changed, because as I said before, file name is not stored here. It just derives from file path. We'll extract from file path our file name. So we'll call those two in the setter. We also need a method for actual log searching by the type. So let's add it, for example, here. Here we search logs with the type provided, as I showed you before, text file. And to make methods available in the QML, you can either edit a slot specifier, so edit to public slots, or add the QInvocable macro. The difference between those two ways is just metadata. Functionality will work the same way, and but as you see, I didn't market getters, these getters and setters, as QInvocable, but they're available in QML. QML calling them, and the reason for that is that Qt will call them implicitly. So in Qt, I will, for example, write it something like maybe my object file path without braces, or file path equals to something without actually calling it. And Qt makes everything implicitly for me. But in this case, we'll execute this method when the button to search logs is pressed. So we have to make it QInvocable. So to make it available in our QML. Let me quickly show you the ready application just so you understand how it works and you understand the logic to easily implement it later. The application will have a button to select file. When you click it, the dialog window opens and choosing a desired file is getting the name of it displayed. As you see here. As you remember, we have a property for file path and property with a getter to get the name of it. And file actually stored is only file path. The next input is the drop-down list where the user can choose what type of logs he wants to be displayed. And for example, I select warnings. Then we have a button to search results in the chosen file. After clicking it, our application opens a file, reads data from it, and displays only the rows marked with the keyword for the selected type. As you see here, we get results from our text file. And I hope you understand the logic. So when we change something here, we change path property. When we change something here, it is stored in QML, and then when we click our button to search, we just provide this type that was chosen by user in the drop-down list, and it automatically displays these filtered logs in text area at the bottom. Now let's implement method we created earlier. First of all, for the file path, but okay, let's firstly refactor and implement everything. We here have set file path, get file name, and search logs. Okay, we have warning, but don't worry for now. And let's first of all make a setter for the file path. Here I want to use QURL and we can include it. Well, let's make it in our header file. Include QURL. I use QURL here because by default we get kind of path like here, like this by default. With this prefix file and slash, but we don't want that file prefix, so QURL just gets us an absolute path. QURL is a convenient interface for working with the URLs and also paths. We could also just use some string method for removing the first characters. As you remember from the previous episodes, there is some kind of methods just to remove certain amount of characters at the beginning of string. But I wanted to show you this class and this functionality. After extracting the path, I check if it differentiates from the previous one, because if the path stays the same, there is no sense in changing data in UI. And as you remember, when we emitting something here, it also changes at UI, in UI. If paths are different, I assign a new one here and emit a signal. So the QML part can handle it and update the display data. I also emit signal for the file name because as path changed, the name is also changed in most cases. The next method to implement is getter for file name. And it is more interesting one because we have to here validate the path property. Okay, let's also include qfile info and I will explain you what it does, of course. Okay, here, first of all, I should validate my file path. property. For a response, if it is empty, if we don't have any pass, then I use q latent one string, and if you don't know the purpose of it, then you can watch my video in the Qt playlist about the string view and latent one string, and you can understand why I use it here for this kind of response. Because as you remember from our application, if the pass is empty, I don't leave my field near the button as empty, but I just write this message that no file is chosen. Then I use qfile-info. Is an OS independent API to retrieve information about files. So you have so many informations inside. As you have so many methods that you can use. In our case, we're just checking if it exists or not, because we don't want to later read not existing file. And if it don't exist, we return this message. And if all validations passed, we return the file name. So also to get file name, we can use this class and here we have file name, file path, file time, and so on. And this is also interesting class. The method for searching logs is going to be the longest one probably. If you are familiar with the C++ way of reading files, there won't be any problem for you to understand what is happening here, because it is pretty similar to just C++ way of reading files. First of all, we validate the path is empty or not. Then we try to open the file in read-only text format, and here the binary or operator is used to unite all parameters. I think you remember it from just some C++ tutorial. If opening file didn't succeed, we just stop the execution. After the file is opened and everything is okay, we can clear the previously found logs and reserve some space to not make a reallocation when we read data. Qt6 stream provides a convenient interface for reading and writing text. We already used it in the first episode, but for the console. So here, until we don't reach the end of the file, we extract text line by line to the string view. Yeah, until we don't reach the end, we provide line by line in string view. If you don't know what QString view is and what is the purpose of using it rather than just QString, I highly recommend you to watch my video about it, about QString view, and also I covered there Q Latin one string. We check if the extracted line starts with the desired type of logs, and if so, we get a log without the type, with the method mid. So here, if you don't understand how this works, then for example, you have this line, info, some text. If you start with type, for example, our type is info, then here I get the length of this type. In our case, this is going to be 4. And then +2, +1, this semicolon, and 2 is the space. So I get this size from the start, and I just extract everything after it, afterwards, this info thing. And I extract my message from the log to this clear blind QString view. Then we append a parsed string to the final result, and I also append it with the new line because, as I said, it is possible to use QString list, but QString is used here just for the simplicity, and so we can easily display it just in the text area. After everything was parsed, we have to close file and emit a signal informing QML that logs were changed. So we can just file close and emit that something was changed, and you have to update data. We should say it to our QML. And also don't forget to initialize the file path in the constructor. Here we can do it because the string can be empty or null. And if you don't know what I'm talking about and what is the difference about empty and null, I highly recommend you to watch my video that is named like everything about QString. It's a pretty decent video about QString and Qt. I recommend you to watch it. We are now finished with the C++ part, and the next task is to make UI. I want to tell you just from the start that it is possible to separate things into different files in QML, but today for the simplicity I will work only in main file. Let's firstly delete everything we have here, and let's start with the imports. Okay, so Qt6 we imported it earlier, just controls, the basic ones. Then Qt dialogs will be used for file picking dialog window. Let me write comment here, file picking dialog window. Then Qt layouts used to arrange items in AI. Arrange items in UI, and I will mostly use column layout for vertical alignment and row layout for horizontal alignment. It is not something complicated that you should worry about, so you will see as I will do it. And then Qt controls, I use it for things like buttons and drop-down list. As you remember, we have a drop-down list, and to not implement it from the scratch, and the same with the buttons, we will use this module. And of course, it is possible to make custom ones, but this is really another topic. And Qt controls material just for the beauty of our applications, of application, and it adds good looking cross-platform styles for our controls. As I saw on video, it looks like okay, and this is thanks to material module. Okay, in the window item, let me create it here. In the window item, I make one column layout that will fill the full window and make margins from all sides. I fill it and make margins, and spacing is just spacing between childs inside this layout. This is property used only in the layouts. Inside it, let's make a group box. Here, group box for our form. It will also add this thin line, as you remember, around inputs. Notice also that when you use layout, you align items inside the layout property instead of anchors. But the naming is similar, so it is not really a problem. As you see, here I used anchors because the parent is not some layout, but in groupbox I use layout for the align items, and here I use layout property. Okay. Then inside group box there is also a need for spacing. So let me create column view for items inside. Here we have it. Inside group box, we're gonna have like column that will represent like the box for the inputs for this file input and for the drop down list. And inside the first row layout, we're going to have a label, a place for writing the file name on or the place for writing the file name or the message about the lack of it, because as you remember here, now you can have this kind of message or just the name. And a button for opening dialog. File dialog is not something we see when we just run the application. We open it as the button is clicked. So let me paste it here. Yes, it's okay. I think I didn't mess up curly braces. Just yes. Yeah, I think it's okay. So okay, we have a row layout inside the label, the text, then text field with the some file name. We will later bind it to our property. As we make the integration part, we'll bind it to this property. And then we have button to open dialog, and on click is just like event we open in our file dialog with the ID. Here inside file dialog, when user selects some file, we get this event on accepted, and we can get the path to selected file that we'll later put here into our setter, the file path. But for now, I just console log it so you see what we get. And the next row layout gonna be a little bit smaller. It will contain only the label and combo box. Sorry. The label and combo box. As you see, we have a label, so we know what so user knows what you have to give us, and combo box is just drop down list coming from the Qt quick controls. And here we specify available options, info, error, and warning, and layout field with true. Okay, under the group box we'll have a search button. So here we have our group box, so we can hide it, and under it, under group box we're gonna have button to search logs. Inside it, when the user clicks our button, I get this current text from the combo box we made earlier. This current text is just option. Let me show you here. As you remember, here we have this combo box with the model, and current text is just the selected one of those three texts. And material background is just used because here we use this module, and now to change some color we need to use material property instead of just default one. And at the bottom we going to have a space for logs. All space that is left is gonna be needed just for displaying logs. I will make it like this. Okay, some mess with the curly braces. Okay, I hope that is fine. So I make rectangle that just fills everything, fill layout, taking all the remaining space. Clip flag is used to hide elements underneath while scrolling. It is basically recommended when you have some list. As you remember, as you probably understand, logs can be pretty long, and clip just makes it available to comfortably scroll it and not have problems. So it is just hiding underneath all elements that is not needed to show to us. I'll show you what it means in a second. So the flickable item wrapper gives us use the ability to tap and hold the list. So you can like type, hold, and scroll. Uh, so if you're going to have large numbers of logs, it is like easy to scroll them with this thing. And the text edit is a place for filtered logs. And the word wrap means that wrapping is done on word boundaries only. So it can go to the second line if it needs. And okay, I think this is it. Let's check what we have. As you see here, everything that we made. As you see, I specified some default text. Later I will remove it, but just now so you see what is happening. And I can select some file, search logs. Now, and as you see, when I click search logs, I console log what the thing that I got here. So I get message, info, or warning, or error at the same with the select file. Let's select, I don't know, I have some random file, and here I have full pass. As I said you before, we got this file thing that will be removed in our setter. And here we also got it in, I don't know if you see it, I hope you see it, but we have it in our output. Now it is time to integrate our C++ class with QML UI. As you have like 3 ways of integrating. Most popular ones is context properties, singletons, and instantiable QML type. I will show you all of them. And let's start with the context properties, or they are frequently also named as or embedding objects into QML. It is the simplest one, and we'll start with the simplest one, and in the end we'll use the most recommended method. Okay, the first way of passing C++ object into QML is with context properties. I want to immediately warn you that this approach is not recommended because you can't really keep track of your objects. And now we will go to the editor and I will show you what I mean by that. Okay, let's make a simple example for the start. In the main function, we can just get root context from the engine. So from the engine, we can just copy, we can just get root context. It's just context for the whole application, and set the context property with the name and value. Okay, and you also have to import this root context because the type QML context, so the compiler knows what is the lane inside. And the very important thing, set context properties before the loading main module. So you need to set all your properties before this loads, before this line of code, because otherwise you will get reference error while calling it in the QML. I mean, it will work, but you will get error, and it is not like great. So here you also need to do that before loading from module, because I mean, you will use it in the QML, and from the, like, you need to start with the loading it, and only then open your QML. I think it's logically understandable. And by the way, QML context, this one root context, is a holder for the objects identified by ID in a QML document. Really, so it's just holding those items that we added ID in QML. The root context is automatically created when by the engine, and the data we provide is available everywhere in QML. So in QML, without any imports or something, we can do it here before everything, just to test. We can add text with my message. As you remember, this is name we specified here, and just let's run it and see what we got. If you run the application here, it's in at the center, not really beautiful, but it doesn't matter. You'll see everything working. As I said before, it is not a recommended way of integration. The reason for that is that is maybe unclear from where it comes from for someone reading QML code, and it limits their usability, since the context may be different in other places where it might be used. So I mean, if you have large application and you have those contexts that's everywhere, sorry, it may be really not clear from where data comes from. So it is not really recommended way of integrating. But we are here not to just show some message. Now let's pass the previously created logs filter class to the context. I mean the object that we will create. When you want to expose an instance of the object allocated before the engine to ensure that the instance outlives it. So I will use here Qscope pointer as recommended in documentation, with the type let's include it, include the logs filter, and here let me just copy and paste. Okay, so one by one I create Qscope pointer to avoid the headache with the pointer, to not delete it and think about it. It just manages everything for me, and I have to have to create it before the engine to make sure it outlives engine. And if you're not familiar with smart pointers, I highly recommend you to watch my video about it, where I discussed all kinds of smart pointers in Qt. Okay, and then okay, I create my object, my logs filter, and then I create engine, and inside engine I said let's make this name, so it will help us. Okay, and I just said that with this key value our object just getting object inside pointer, and now using this keyword we can make some changes in QML. Let's start from the beginning here when we wrote some strange data, just so it be. First thing, it's a text field. Here inside text field we should edit and call file name. And as you remember here, we specified property file name. It have this name. Then in the file dialog, instead of outputting it to the console, we can call the file path setter, which is also emitting the file path changed signal, so remember. So here file path equals to file path, this variable. Fine. If I run application, just to show you, if I select some file, I found this file I previously created with logs. When I edit, I get here name of the file logs.txt inside this text field. And as you understand, everything works. Our signals and slot works because, as you remember, I just here specified my name of the property without calling getters, without something. I mean, it called getters underneath, but I am not writing this logic by myself. And see, no files chosen. I select some file, and it updates. So fine, our path is also updating, and here when I using equals equal sign operator, then my setter is called. So here my setter, this one is called because I specified in file path write to the set file path setter. Okay, when the search button is clicked, we should call also a method for searching with the given parameter from the combo box. So logs filter, search logs, and we give here one of those three options. As you remember, here we got this type thing, and there is method that we are calling, and it's also specified as QInvocable, so it is available in our QML. And also let's change text edit content from logs here to filtered logs. Okay, if we run the application, as you see, everything is working. For example, we select error, warning, and so on. And by the way, I didn't really properly explain what clip is about, but as if you tap and hold, you can scroll. And you see this text is underneath other components. So that is what clip does. So when you scroll, it is underneath other components and just uses this box, this text area that have. So it's all about this. So okay, I select file and I can search some logs, and it works fine. Just to wrap up, content properties could be okay for some global static values, but we have better options for this kind of stuff we have today, this kind of program. And the next thing is singletons. First of all, let's clarify what singleton is in the programming context. Singleton is a creational design pattern that ensures a class has only one instance while providing a global access point. It's just definition from the internet, from the Wikipedia or something. I mean, really, you like have your class and you create only one object, and you make sure that this object is really one created for all application. And the main ways to expose singletons to QML are imperative, and this is older, type registration using the functions provided by Qt, like QML register singleton type or singleton instance. But the imperative type registration is an older way of providing singletons. The major disadvantages of this approach is the impossibility of extracting necessary information about the module at compile time. So it is too unfriendly. And it means that just you won't get any hints inside your QML because it is not possible to define what properties you have at compile time while using this imperative approach. And also, if you use this approach in large applications, there will be big chunk of code just repeatedly registering all classes and instances. I mean, you'll just call these functions one by one, registering everything, and it's not really beautiful in big applications. But it is still frequently used, so I will show you how to use it also. And registering a class with certain macros to provide singletons. It is possible with the Qt6 or higher, and I really like this approach. You just add some macros to your class. You don't need to write anything inside your main function, and it is really great because you add macros and you have your singleton inside QML. You can use it. I will certainly show you this method after the imperative one. Okay, so how it looks like in code. So we have our main. Let me just comment this out and write that it is context properties, and now we use first of the singletons approach. And here, as before, we create our object as a smart pointer, then create engine, and then we, with the help of this function, we're registering the instance, not the type, because we can register the type or we can register the instance. When we create some object and then register it, we use this instance thing. And the first parameter here is the URL of the module that will be you will import later in the QML. So you're gonna need to like import it the same way as this imports. Okay, then you pass the major and minor versions of your module, and finally you pass a name that will be used to call your object in QML. Let's also make it with the small L letter to not change anything inside. And you specify pointer to like object that you want to use. And now we can go to main QML and add this import. So we import our module and add also versions. It is not required to add versions, but just good practice to add it. And let's run. Oh, we have some error. Oh, oh, yeah, okay. We should change it to big letter. And now let's... Okay, sorry for that, but we don't have really a lot of code here, so we can, I think, easily replace just all uses of logs filter to the capital letter. And now let's check it if it works. Yeah, it works, and we can select our file and then select, for example, error, and let's see what logs we have. And that works pretty nice. But if you go here and write logs filter, then dot, as you see, you don't have any hints. So it would be really great if editor writes for us that we have like search the logs method or some another property, but as you see, editor don't give us any hints. And this is an example of tooling of unfriendliness I told you before. Okay, let's now take a look at registering types instead of instances. So here I registered the instance, but we can also make registered types. When you register types, Qt doesn't care, it doesn't create an instance for you. Instead, you provide a callback that returns the instance of your object and ensures that it is single, to not violate the singleton rule. Inside the logs filter class, we can add method that will return an instance. So here we should include QML engine, because the method that is used to create instance, this callback, is taking some parameters coming from this header. So in here, let's just edit. So it is static method to get the instance of our the class, and this method, and we should make sure that the instance gonna be single in our program. And really, the implementation of method gonna be really easy. So if I go here, make it like this. So we specify our static uh, static member inside class to store this single object, this single logs filter object, and then inside the instance method we just check if it exists. If it don't exist, we create a new one, and if it don't exist, if it don't exist, we create new one. If it exists, then we just return the one that is already here. So it just makes sure that in our program we have only one instance of logs filter. And then inside main, let me also comment it, and now we can make something like this. We create engine, then we registering our type. Here we registered with registered instance with this function. Now we're registering type with the type logs filter. We specify name for the module, version, the key to later call it, and we provide here the callback function. This callback function will be called to create our object. Also here I didn't told you probably that what those parameters are. And our method takes this QML engine and QGIS engine mostly for historical reasons. So I don't even provide a name for those parameters because I don't use it. And probably there is gonna be a moment where you need to use it, but in our case, there's no sense to even give the names for them. And now, if the names are the same. It's also my import logs filter. So now, if we run application, everything should work just fine. But now, just Qt creates for us the instance of our object. Now, if I select logs, and as you see, everything works. Okay. The last, simplest, the most recommended, and just my favorite way of defining singletons is with default constructible class and QML singleton and QML element macros. With Qt6, this way was improved, and now we need to neither register it in the main or CMake. So we make everything inside our class, and we don't have to change anything inside CMake or main function. Okay. Here in our class, we should first of all include this header. It contains the macros that we need right now, and we can add macros QML singleton and QML element. This will register the class by the same name in the QML module file belongs to. Okay, QML element. This macro registers class as an instantiable QML object type, and QML singleton provides that singleton functionality where you have only one object. So okay, this one registers object inside the QML, and this one makes sure it is single, and we will access it by the same name as we have in our class. We can change it, and I will show you how. Now let's go to the CMake lists. We don't need to change anything here, but we need to take this URI because, as I said, this will register the class by the same name in the QML module file belongs to. So we have this module and our file belongs to this one. So we need to copy and import it. And if we just try to execute it without really changing, oh no, sorry, I forgot to comment it. No, it's commented, and now we're using really the method with this macros. And if we try to select some file, everything works fine. It's already fine because we just added two macros and we don't need to do anything more. But the important thing to mention is that you can rename your class with the QML named element. Here you can specify this macro and you will access not with the name logs filter but with the name other name. We won't use it for now. Also, if you don't have a default constructor, this one with just one parameter parent, then you have to define a static create method. And let's say I want to receive a file pass at the construction step. So, for example, I have my constructor, but I want to modify it and receive also pass. And here the same, we need to modify it. And now we just passing our pass here to mfile pass. Okay, fine. And also here we got problem. It is not really important for now because we don't use it method. We can just comment it. But if you want to use it, you just add in here inside some value. It is not really hard to do. And if you run it with this modified constructor, let's try, you'll get so much errors. And here something has broken. You get many errors, type error, and so on. To fix it, we got to define a new method that returns a newly created object. And this method should be named, because previously we created this instance method that could potentially have other name. I just named it because it is logical, and later we provide it inside function to register singleton. But here here we have to add method name with the name create, and inside this create method we are just creating a new empty object with the string that we want to provide. Now, if we try to run it, everything works as expected. So you can choose and select your logs. But you probably wondering if there is no memory leak because you like creating with the new and it's looking a little bit scary. The answer is no, because the QML engine will assume ownership and delete the object. So don't worry about it. Okay, and we have the last method of integrating is instantiable QML type. There is a way to register an instantiable instantiable object type to QML, so you can just register this type and create how many objects you need inside QML, and it is very good method to integrate your C++ class with QML because it gives you so much flexibility. Okay, let's go to the editor, and for now Let's go back to the default constructor. So I remove QString pass from here and from there, and just make it as it was. And here this thing we can also comment. Also comment this one. Okay, and let's also comment the QML singleton macro, because it is not singleton anymore, but QML element, because we want to, as you remember, QML element registers it to the QML. So we don't want to remove it. And I will show you firstly the simplest case when like you have default constructor and this QML element, but we should add now our class to the CMake inside CMake configuration. So here we have a Qt add module, and you just need to make sure that you have it here. Probably it is already registered, but like make sure. Okay, and now if you go to the main QML, here after importing it, importing that module, you can create your objects. So for example, inside the window, before everything, like let's go do here, we can just create, for example, two objects, logs filter, and it will be 1 and 2. And we can also specify default values. So we make two instances with different IDs. Notice that we can provide default file path, but we can do it, for example, with filtered logs, because we don't have a setter here. But here we have setter, so we can do it. Now let's try to change every usage of logs filter to this logs filter one. It won't take much time because program is not really large. And here. And if we run our app, and as you see, everything works as expected. You can choose, you can select. Okay, fine. And I didn't show you this with the previous one, with this good with this second of the singleton methods. But here, if you write, for example, logs filter, this is what I talked about with the tool in friendliness or unfriendliness. That if you write this dot, you can see what you have inside, and it's really handy when you're developing your application. And if you want your class to have not the default constructor, for example, because here I go back with not providing pass, then you need to just create the second one, just the overload for it. And let's add it here and specify values. So there's no need to create something like here with this create or instance or something. You just create overload. So if we run it one more time, let's check if we don't have any errors. Everything works, and that's fine. And but if there is no if there is only not non-default non-default constructor, if you don't have this base one, then you'll get error from QML while trying to create an object. So be careful, and also always add a default constructor and your constructor that you need. And I think this is it. We covered all ways of integrating a C++ class to your QML. Now you can make your application that you need, some simple one. And don't forget to hit like and subscribe button. It is really helpful for me. And thanks for watching. When developing a Qt application, sometimes you want to display images, videos, GIFs, or change font to a special one. Today, as always, I will show you the most commonly used ways to do it. Let's start with the basics. The Qt resource system is a platform-independent mechanism for shipping files in an application. It means that because of the way Qt works, every time you have a certain icons, videos, or whatever to display in QML, you must add it to your application in some way. But what are those ways? The first method is to add a Qt6 file and register resources inside it. It is just the XML where you specify files to load. In the compilation stage, the resource compiler, or simply RCC, starts his job. RCC reads provided resources and generates a C++ source file that contains a tremendous array of bytes that represent the resources you want to load. And finally, you will be able to use registered files in QML by adding a special prefix before passed to it. I think the best way to understand it is to use it practically. We'll make a simple app to display the kind of user profile. There is profile images and links to social media accounts. You will see how to make some layout, how to display images, how to load fonts, because as you see there is special font, and how to make this simple app. I already created my Qt quick application, and by the way, full code will be in the GitHub repository. Let's quickly just remove the stuff that we don't need, and rename it to, I don't know, profile. Okay, and maybe make it 700 by 700. And let's make width a little bit more like this, and rename it to root. Just basic setup. And here there is my project that I created, and here I also added images to display and the random free font I want to use. I mean, you can download it. I will put link in the description to where I download those icons and this font. So I just added folder named assets and put it inside. Okay, now right click on your project, add new, and here you'll have in Qt resource file. Name it, for example, resources. Next, finish. And as you see, Qt Creator gives us a graphical interface, so we don't have to edit the XML directly. You can add prefixes to structure your assets, then add files to created prefixes. Let's make like icons. Where I will put my icons, then avatars, where I will put my avatar, my logo, and fonts, for example. And inside it, I can hit add files and go to here assets and select what assets I need inside this prefix. Then it files my logo, and the same with the fonts. Here, font. If you open resources Qt file with the text editor, you can see that it is just the XML. And here we register our RCC in our RCC with some prefixes, some files. And there also you can also use some attributes, and you can read about it in documentation. It's not that hard. There are not so many of them. In order to use the resource compiler, you have to edit cmakeLists file. See, we already have something inside our file explorer, these resources, but to load it later in QML, you also need to edit your CMake list. First of all, we should enable auto RCC. It will initialize the resource compiler on all files, and the only thing left for us now is to add here. Here we have Qt add QML module. We already added it resources, because if it didn't add it automatically for you, then just add resources and the name of the file with the resources. When you build up, now let's build, it will take some time because the resource compiler embeds all files right into the executable, as I showed you before in the presentation. It embeds a file and creates the tremendous bytes array. In the main QML file, I will make a row layout to divide two sides of the window. So first of all, we should import layouts module, then add this row layout that will divide. This will be like a container for those two sides of my window, as you saw on the presentation. And inside this row, we're gonna have two column layouts to represent those sides. And inside first side, it is a profile images. So here I just put width to this parent, this container divided by 2 to take the half of the window, and inside image I align it to the right, so it like stands at the center. And the most interesting thing is here in the sources, in the source. By the way, to display images, we use the image item. Inside the source property, we specify a path to our file. Because we use resource compiler, we should add a QRC prefix. So Qt knows where to search for a particular file. And if you don't want to write this full path, you can just go to your resources here, and for example, click at this logo and copy your resource path to clipboard. Then go to main QML, and here just Ctrl V, just paste it. But don't forget to add QRC prefix. And of course, you can change this prefix. You can read about it in documentation. And before we make the second site, let's add a custom item inside another file that will helps us display a social media logo. Name of it and make links to the external resources. Because as you remember, we're gonna have like 3 links looking pretty much the same way, just changing the link, the URL and name of it, and pass to the image. And to not repeat my code so many times, because it's gonna be so large QML file, let's create just new one, not in the sources, sorry. Just click on your project, then in Qt, add the QML file, and here name it, for example, profile link or something. Finish. Here you have item, and first of all you're gonna need to import layouts, because if you use layouts, use it use it everywhere. And here I make an entire item as a row layout because it will lay inside the column layout. So here I will make second column layout, and my row layout's gonna lay inside, and to not mess anything up. And the image with the text should be near. So in the row layout, it is like stands on the one line, just near. And so, okay, properties are just fields inside my item that I'll be able to fill with some data. So from my main, I will be just able to provide some string in this case. For example, I can source, link, or label, or whatever, and you can make your properties. We will, in the next episode, we will discuss more in detailed way QML objects and how everything works, but for now it's simple. Okay. Next you have image, where I provide icon source in the source, and then put some width and width and height. Then in the text I just provide a label. name of it. As for now, it's not link, but I will show you how to do it. Just not everything in 1 second. And here we create, as I said, new column layout. Okay, I copied from Word, so it is a little bit messy. Sorry. As I fixed everything, and as I added column layout, put the same width as I specified before, and put 3 links inside. So I don't have to import anything, okay, because it is all QML files that those are registered in my CMake, so don't worry about it. And inside main, I just create 3 links where I specify icon source. As I said, okay, here Instagram. As I showed you before, how to provide those URLs and how to copy them from the your resources file, your QRC file. Then I provide link. Of course, you can use your profiles. It is not really matter, and I provide name that will be displayed, I mean label. And if we run the application, let's try, let's save everything. As you see, everything seems nice and working, but text is not clickable, it is not links right now, so we can't reach the hyperlink we provide, and also we have to change the font, so to make it more interesting, you know. Okay, to load fonts, we go to here, to profile link, and we can use font loader. Okay, let's make it after the properties. Font loader item. Font loader item just allows us to load some icons, but if you have a lot of fonts, I recommend you to separate font logic into another file, to not repeat the same logic again and again. But just specify what you need later. So you create one object with all fonts and just then specify what you need. But in this project we have some text only here, and it does not make sense to make separated separated classes, separated objects. So I load it directly here, and then we can go to the text and provide font name like this. And to make it like a link, we can provide a mouse area. We can add mouse area. So mouse area, as you remember from the previous episode, just manages the way our mouse moves and handles some events like on clicked, on enter, on exit. And I enable the hover, and when mouse entered my link, I change color to blue, and when it's exited, I change back to black. So okay, if you run the application, let's see if everything works. As you see, we have our font loaded because we provided path properly. And then we have links. We can go to my profiles or something, or your profiles, doesn't matter. Okay, you can also avoid creating QRC files and add in and register your resources directly in CMake list. So here you can just disable this auto RSS, then let's comment the resources, and what you can do also is just edit like this. So you just provide every resource that you want to load, all the images, fonts, and etc. In this case, as I said, you can disable auto RSC because CMake doesn't have to process it, and then you can use your files without any prefixes and in QML. So for example, here you can put just facets, logo PNG, or let's go next here. I have icon source, let's comment it so it lay in my repository, and change it to just assets, assets Instagram PNG the same way we can do here. Let's put just assets YouTube PNG, and the same here, comment, and here assets medium PNG, and there is fonts left to us, so everything works. So go here, I'll also comment it, and provide new path to my font. Okay, because here, as you remember, we use prefix, then path to our file. It is not very comfortable, of course, to add files one by one in CMake, because suppose you have many files and you don't want to take hundreds of lines in your CMake to load them, because it will be like pretty big CMake list just loading the resources that you need. But if you have a directory where all files should be loaded, for example, like I have this assets folder and every file inside should be loaded as a resource, then consider using something like this. You can, so what it does, and here also I'll comment it. Okay, sorry, I'll comment it and put new thing. Here we use the power of CMake and make a list. This will be a list of files recursively loaded in assets folder. So here, if you want, you can read full documentation of the file function in CMake, in the CMake documentation, because I will now explain just the basics. So this argument will allow us to search files recursively in assets folder that we provide here. Then we specify the directory where we search and folder where we search. File asterisk means all files inside, and we put everything to assets files list. And here we don't need to write everything just line by line, and can just put resources and this list just as a variable. Of course, and if we run, I didn't change anything in my QML, and as you see, everything works. So you can go medium or something, everything works. And that is fine. This second method, by the way, where you load your resources directly in CMake, become available only in Qt6. And it is your choice really what to use, because QRC gives us more functionality. For example, you can make aliases to your files in QRC file. Maybe not here. Here you can put some alias and do not write this long thing, this assets local and whatever. Or you can also put different files for different locales. So you can choose what local user have, and depending on this, put different files inside. But as you see, registering in CMake is a little bit faster. So it is depending on your specific case and on your specific goal. And okay, I think this is it for today. I really thanks you for watching this video, and I hope you'll subscribe and hit the like button if it was helpful. In this video, we're gonna discuss one of the essential topics for the large QML projects. QML module provides versioning types and JavaScript resources in a type namespace. By the end of this video, we're gonna make this up with buttons module for items you see and styles module for managing colors and theme. Okay, let's add a little bit of theory before we jump into Creator and make our project with QML modules. So why do we want to use QML modules? The simplest answer is to separate logic. Most applications have many functionalities, and if you throw everything into the single directory, it will be such a mess. Also, modules allow us for type versioning. A module is defined by QML dir file. Each module has a type namespace, which is also an identifier. So in every directory, we're gonna have this QML dir file where we specify identifier of the module and the files we want to add inside it. So let's start making our application. First of all, I want to create the folder structure, because here you see we have default one, and that's not good for now. Okay, we will use a module for styles that will manage colors, and a module for buttons, where we will create a base button and inherit 3 different ones that will be used in main. And okay, so you can just right click and show in Explorer. I already opened it, my project directory in Explorer. So here, let's just create our directory simply, because it will be faster than clicking inside creator. Okay, the first is gonna be components, and inside components, let's add buttons module, and inside button module, let's, as I said, add first of all it's gonna be base class for the base type for our button. It's gonna be custom button QML. Then I will just copy it 3 times and rename to, okay, primary one, the secondary, and danger. So if you worked with some CSS libraries, you understand what I mean by those buttons. Just this is base one, and here we just specify some colors, so we don't have to repeat every time we use it inside our code. And also in every directory where we have some, each directory with .qml files should contain QML dir. So create QML dir. For now, let's leave it empty, and we'll put something inside when we will add it to our solution. And also, when creating a QML document, be careful, because the name of it must begin with an uppercase letter. Okay, also, let's add the style module, and inside it, styles QML, where we will just predefine colors in our project, and QML dir. Okay, and now we have to add the created file structure to solution. So right click on your build, add existing directory, and here just select components and style module, because you want to add everything that is inside. Add, wait a little bit, and creator will add it to your CMake. Here, as you see, just one by one. And as you see, we have our files. And to avoid QML warnings about import pass and problems with finding module, we can add an import pass. So basically, let me specify it, and I will explain why I do it. So after loading, so before loading the QML file, we have to add import pass. We can do it that way. But here I have tutorial 10 video, so I just changed to my project name. Okay, and why I do it? We specified the path in our project because that is where QML modules are laying. We will not write an absolute path to the files we want to import. I mean, later in main, for example, when we want to import module, we won't write absolute path. So instead, we'll just make use of module identifier. So QML should know where to search for it. And so we don't get any warnings when writing code, we gotta add this import path. I want to start with the style module because the second module will make use of that one. So let's go to the styles QML. I will just paste and explain you what is happening here. So some parts of the code can be new to you. So let me explain everything. The first line of code, we mark our item as a singleton. It works the same way as in the C++ singletons. So Qt create for us one consistent object and we can get values from it without instantiating. So later I will just able to write something like styles and my color, background color, for example, without instantiating it, because it is singleton and it is already instantiated in one object. So we don't have some unique properties, we just make constants to use in our UI. Earlier, to make some basic items, we used the item type here. We make it like that. So as you see here, I use Qt object. The reason for this is that item is a basic type for something that should be displayed, but Qt object is kind of like the most basic type of the most basic type in QML. It's like your object in C++, that can be displayed but can store values. So difference between that is there's just okay, let me write item can be displayed Qt object store values, and it's just kind of optimization. Inside it, we'll make an editable theme property and a lot of color properties that depend on the theme and can be changed because it is read only. So here, when we can change. We have dark theme or the bright one, and depending on that, colors gonna be changed. So I'll use for now just dark theme, but I wanted to show you how to do it in like real apps to not make some if statements. I mean, we make here if statement, but one time, and it's inside one object. Okay, and inside QML dir, let's go here. I'll show you what we should write to add files and make module. We specify the name of the module and the items inside our module. Be careful because the name of the module, this one, should be, must be the same as folder name. Here we have style module. And unfortunately, that line of code on top, pragma singleton, is not enough for QML, and we have to also add the singleton flag here before our file. So here we specify the name, how we will call it later in when we make use of our module, then version, and then file that implementing it. Okay, and let's just right away test the newly created module. So here, let's add the background to the main window. So, because as you probably remember, we got this dark background on presentation. So let's use import style module and provide version 001. So okay, as I said to you before about this import pass warning. Okay, let's left it like this, just test if it works, and I'll then will show you how to fix like the warning, because without it, without this line, it just won't work. And we also got to fix our creator. Okay, and here I just add a rectangle to my window. So here I import styles module and specify the version I want to import. And remember that the name of the module must be the same as directory name. Just remember, and then I'm adding a rectangle that fills the full window and lays under all other items. Z is like a layer, because earlier we used only X and Y, but Qt supports three dimensions. And here for the color, as I wrote you before, just use styles, this name, and background color that is laying here inside. Okay, let's try to run it. Save QML there, and let's try to run it. Okay, we have some errors. Let me check what I done wrong. Okay, what has happened is that we created these QML files, buttons, and leave it empty. So we can do it. So for now, just rewrite what I have. I import Qt6 and here I create item in custom button, and in the three left ones I import the same, but inherit this type from custom button. So I mean maybe not inherit, but make my item based on custom button. So indenture button primary and secondary the same way. So for now, just copy and paste it, and later I'll explain what is happening. So now if I run, I have my background, as you see, but we have this warning, and if you go to tools, QML reset code model, this not leaving us. So now we gotta use CMake, because as it is written here, for CMake projects, make sure QML import pass visible in CMake cache txt. Okay, let's go to the CMake, and after adding our files, let's also add this QML import pass. So here what we want to add is, let me explain those lines if you're not really experienced at this is a CMake user. Here I create list and append list name at QML dirs and append to it CMake source dir. It's just the directory where all our files are laying in this one. I mean. Okay, and then I set this QML import pass the same as we got in my warning. Warning is already gone, but the same as it was in warning. And inside I set to QML import pass my list, because in CMake list, I pass it like a string, because in CMake lists are just like item 1, then item 2, separated like this. So it just can be string. And by specifying the string, we'll just bind in the cache to this name. Or I don't know how to really call it, but you can just copy, or I don't know, maybe leave just Qt creator and your version. Or if you use it now for just testing purposes, you can write here what you want. Just how it will be assigned in cache, and now if you save it and your project will rebuild, you see no errors, no warnings are here. And if warnings still there, then you can go to tools, as I showed you before, QML, and reset code model. It will force Qt creator to think one more time. Is it really warning? Is it really okay? I mean, process one more time your QML code. Okay, let's go to custom button, and I'll just paste and show what is happening here and implement it. Okay, let's start with this basement. If you use just property, like here, then one directional binding is made. And using this data in some item, for example, to set the text can cause the data to be out of date. In styles, we made a singleton object, so it is not really a way to make an alias. But here, as you see, I use alias. And alias keyword makes the binding bidirectional. It means that wherever we change the value property, it will be up to date. And here I specify where I want to pass it. So if we change this value on the run, then everything will be up to date. If you remember from the beginning of the video how this button is supposed to look, then notice that the border and the text color have the same color. And I done it just for the simplicity from one side, but from the other side it will make a little bit overhead right now, but it's okay. I'll show you how to do it. So the color of the border and text is the same, and when we hover on it on button, then the colors are changed to the background one. And unfortunately here, because okay, let's start from it, because here button height and width is like obvious, but why I specify it here and then specify it here, because rectangle is kind of like absolute item. I mean absolute, if you're familiar with CSS and HTML, it means that it can lay on other rectangle simply. And here, so it have some shape and it is laying around our layout in sensible way. I'll specify the width and height of inside item. Okay, then I have background color, and I pass it to rectangle color, then text color, and button and text. I pass it to text, to button text and text. Here text color I don't specify, I don't pass it nowhere, because now I will show you how to do this interesting binding with switching colors. And as I said, unfortunately, you can't pass two properties to the alias, but we can figure it out by adding some kind of middleware component between them. Because what I mean, in the perfect world, we could potentially like write something, button text color, and specify the color, and we also want to add a border, so it will be perfect if I could write something like rectangle border and color. But we can't pass more than one parameter in our alias, so we got to make something with it. And now update the version. What I have done, as you see, I pass a text color to the new rectangle component that will be not visible, and then I used it inside my rectangle and text components. So here I add the text color. I have text color property, pass it to the shared rectangle, and then from the rectangle I use it in border color and text color. So okay, fine. To not getting back later also, I forgot, let's declare all buttons inside the QML dir document. I'll just copy and paste. Here, as you see, I added components and dot before the name of the folder, because here the name of the folder. Why I done that? Because, as I said before, the module identifier should be the same as a directory, and here we have first the components and then buttons module. And when we got this parent folder, we gotta add a dot between them. And as before, I specified the name, how I want to call it later, file and version. And buttons not are not singletons, so I use it without this flag as I done in styles. Okay, let's go to main and just quickly test our custom button that we created to make sure everything works correct. And now import components buttons module, the same as specified in QML dir. And here we can add our custom button, unknown component. Interesting. Let's try to run it. Oh, sorry, because here I misspelled. Oh, and now fine. We have this click me fine button. And now I didn't use my styles. Here I just passed some static values because I will remove it later, and don't worry. We'll use buttons from danger button, primary, and so on. And notice also that we are passing anchors property, even though we didn't specify it in custom button file. It is possible because the root of button is item, and really custom button is kind of override of item. It's just like about because for someone it can be not obvious because I don't specify it anchors as a property, but I pass it. So how it works? That's how it works, because custom button is kind of override of item, and we just can pass it like this. Then specify width, height, color, text, color, and text. And as you see, I have color of the border and text set to white and background to red. But I pass only once this white. Okay, fine. If you run it, it looks okay, but we haven't implemented hovering and clicking logic yet. So let's do it. Go to custom and okay, how to fix this warning? I think we can just reset code model, and yes, it works okay. So go to custom button and here maybe after. Okay, let's make it before. Okay, I added this chunk of code. Just if you're interested, I mean, if you try to implement it yourself. And because I want to change text color and background color back and forth on hover, I defined two properties. They won't be changed, so they're not aliases, those ones. And I assign them to pass it once when component is loaded. So I create two properties, stored background color and stored text color, just to cache it, because later I will change those ones, so to switch. So here, when component is loaded, I store them. And then I also added signal to click, but wait a little bit for it. Let me explain firstly this, and then I add mouse area that helps us to add this hover and click events. Include the parent is item, then enable hovering and write this logic. So when entered, I change the root background color, this, to stored text color, and text color to stored background color. So because those are aliases, it will change in all items where they are passed. And on exit, I change it back to the starting point. So text to the text, background to the background. I also added the click signal here, clicked, so that I can pass slot in main and can handle click event. Because here I just when click it, I call this signal, and later in main I can specify what will happen. So like this here in main. The signals and slots in QML work the same way as in C++, so if you don't understand it, then I highly recommend you to watch my video about signals and slots. So I passed this slot. Let's test how it works. Okay, when I hover it, nothing is working. Fine. Let's find out what is happening. Sorry, okay, I noticed here because I just copy and paste my code, mouse area should lay inside the rectangle, of course. Because here I already created it, but I'm sorry. Just paste it to rectangle, inside rectangle, and now it will work. Here, as you see, I have this button. When we hover, it change colors back and forth, and when I click, clicked message is written because we pass slot here, and that's cool. What we have done already is good, a good basement, but if you have ever worked with the libraries like Bootstrap, there are always some ready-to-go buttons where you don't have to provide any colors, like this, and just the text and optionally sizes. So I want to make three different types of button. I mean, I created it, but I want to implement it right now. So let's start with danger one. Here, then primary. I'll explain right now what is happening with them, and secondary. As you see, the implementation is pretty much the same. All I change is like because text color is the same, in every button, so I pass the same. I just import it from my module, then specify background color. In our case, in danger, it's gonna be some kind of red, a primary blue or something, and secondary yellow. So I just created from the custom button and specify properties I want to add. And see, here I specified more of them, but it is okay. It will work without, for example, like something like width. I will be able to specify sizes and text and a slot later in main where I use it, because in those in those types it is just like middleware. I mean, I don't know here what I want to do in on click, so it is just reusable components, you know. So I'm doing this to avoid the copy on the same lines of code every time I want to instantiate the button, because most of the times application have similar buttons and there is no sense to provide the same color every time instead of use this prepared classes. So let's use our new components in main. So here, rather than I deleted the previous code with a custom button, add column with spacing and centering, and here I use first the primary button with width, height, text, and the slot on click, then secondary button, and then danger button. So if I run it, okay, it's interesting. Okay, let me see what I done so far. Okay, so I noticed one thing when I copy and paste my code, I messed it up and I deleted those lines. And as I said, you see this error. Like if I don't edit, but I provide width and height to rectangle, that's what I see. Really, here buttons are laying on each other just. And if I edit, then you see I have my buttons just as in the beginning of the video. And if I click, I get my messages. So as you see, in that way we can create reusable QML modules. And that's really all I got today. So thanks you for watching and see you in the next episode. Most applications need some large data presentation. Earlier, we only displayed static data with simple components like a single text, buttons, etc. Today, we will dive into models and views in Qt, and I will show you how to display large data sets in your application. For example, views, tables, grids, and so on. The plan for today's video is to cover C++ models and views in Qt Quick. By the end of the video, we will make this list application with all CRUD operations. So we can create, read, update, and delete data from the list. Model view is a class that contains the data and its structure. QML provides us with a couple of models like list model, table model, item selection model, etc. But most of the time you will create your own custom one in C++ using a Q abstract item model or a class derived from it. So as you see, it's like quick presentation of from the Qt documentation how model and view work together. So model contains data inside it and structure, and the view is just for the rendering part. A view is a container for displaying collections of data. Qt Quick gives us a set of standard views like list view, grid view, path view, table view, and tree view. They're all customizable, and most of the time you will use one of those standard views because they really fulfill your needs and you can customize them in all kinds of ways. And as you see here on this graphical representation, view renders, model manages data and some business logic. Let's take a look at those views in the example project. So I just created project, and let's create a new file, QML file. Let's name it list example, and it's QML file. Okay, I will paste the full example and explain what is happening here. And also we got to import Qt Quick controls. Okay, As you see, here we created list view and provided the model. So I told you before about list view. It's the type representing data, and the model is just where we store the data inside it. The model contains list elements, where each one of them has properties. But in the case of models, we call them roles. And you will see why I mention it when we will jump to C++. We also provide a delegate here. There is just a template object that will be displayed for every list element inside a delegate. Use name here, name and email roles inside the text to display data, and they are matching with those roles here in email. So to summarize, we have list view. That is the type to display list. Just we specify some height. Also, all those views have spacing, just spacing between elements, so they not like together. They have some gap between. And then we provide model. That is just a list model. Later we will create this in C++, our custom one, but for now I just want to show you an example. Inside list model, we just create items like in just list. Each one of them contains roles, name and email, and later in the delegate is just template for each one of elements in list that will be created for each of those list elements. And we use name and email roles to display some data. Okay, I repeated it twice because first time it may be hard to understand just right away. Okay, now we can go to main, and I will create a column layout because later we will make a grid, buttons, and so on. And also I have to import Qt6 layouts because column layout is from the layouts module. Okay, we have our list with all the elements we provided. Let's run and see what we got. Here you see I have this list. And by the way, I didn't mention, but I think it's obvious, frame just adds border to our element, so you see the boundaries. I mean, you can replace it with item or whatever you like. Okay, we can customize it and add a header and a footer to this list. I also okay, let me paste my code. So we can specify here header. It will be just a rectangle with width the same as our list, with the height 30, background color, and some text that it is contacts list, just as you saw at the beginning of the episode on my presentation. And let's also add footer. By the way, you can just select it and hit Ctrl I, and it will fix all those tabs and spaces. Okay, I also pass footer positioning here, so the footer is always visible at the bottom, because you have different ways of presenting your of positioning your footer. You can read about it in documentation. It's just like it's overlay, or it's just at the end all the time, and like this, not some hard things. And I also provided z value in the footer, and it can be different. Just make sure it is bigger than in delegate. In delegate I didn't specify nothing, so 10 is okay. Maybe I can pass 5, for example, but it doesn't matter, just so it lays on top of the last element, on top of the last delegate. There are also so many properties you can provide to your view. For example, you can add remove animation, selection, highlighting, etc. You can just go to documentation and see, because there is a lot of those properties, and I just won't be able to show you each and every one of them. And it's not hard to specify. Like here, I just pass a rectangle, and it will work right now, I hope. Let's see. Here, as you see, I have my rectangle with text, and on the bottom just my thinner rectangle, its footer, and 3 elements inside that I created. Okay, now let's explore grid view. Grid view uses the same list model as here, but displays it in different way. So let's move out data to separate file. I will just create a new file with new QML and name it example dataset, just this list. And I'll extract from list example, pass it here, and fix spaces and tabs. Okay, and here I can just write example dataset, create it as a type. Let's check if it works with our list. So we can continue with grid. Yes, as you see, it works, and that's fine. Let's now, and in that way we can just avoid copying the same code over and over again. So let's create document for the grid and name it grid example. Okay, fine. And here, let me just copy and paste this code that I have. Example dataset. Fine. Here, just like before, I pass some width and height, then I pass model, the same list model with the list elements, and then delegate. Here we use pretty much the same technique, but if the delegate doesn't have enough space horizontally, it goes on the next line. You're also able to specify cell widths, height, and other unique for grid properties. But now I only show you a quick example of usage because I want to make this example with list just more complicated with C++, and to not spend your time on showing just the controls that you can test on your own simply. So let's put it in main. Also great example, and let's see how it looks like. And you see, as I said you before, when it doesn't have enough space, it goes on the next line. So here I just create text and the next text with the same rows as I done it before, and center it horizontally and put it in columns so they stay vertically aligned. So you basically saw how to create a model with some rows and display it in a list or grid in your QML. But we have done it in QML, but the problem is that QML is not that flexible, and when you probably will want to integrate your application with the database or other sources, and then you will have certain problems. Now I will show you how to create a model in C++. Firstly, we will make only the displaying part, so QML can just get data from it and display it in views, and then we will implement create, update, and delete functionality. Before we start, let's discuss two very important classes we will use to create a model: QAbstractItem model and QAbstractList model. QAbstractItem model is an abstract class that defines the standard way components work with each other in model view architecture. If you don't remember from some basic C++ tutorials what is an abstract class, it is a class that can't be used directly. We must subclass an abstract class and create our new class by overriding some methods that are custom for each case. So we just have to override some methods because they don't really implement it. Okay, and Q abstract item model uses Q model index for managing underlying data. Q model index consists of row and column, so data is stored in a hierarchy of tables. But if you want a simple list, then it is just a table of rows or columns. So you just select your one dimension that you want to use, and it is not a problem. Every record inside the model can also have parent index. It is made for hierarchy. For example, views like File Explorer, like in File Explorer, where you have folder and parent, and where you have folder as a parent and files as children. This class provides you so many methods you can implement, and they will be used by the view. I will later, when we will implement, I will show you how many methods you can possibly override, and you really can do whatever you want with it. But you don't have to always use QAbstract item model and implement everything on your own. There are common usages of this class, for example, a list. Qt provides us with the QAbstract list model that is also abstract and also has to be subclassed. But as the name suggests, it is already a non-hierarchical sequence of elements. QAbstract list model is a subclass from QAbstract item model, so it is just an improved version for specific needs. And remember that QAbstract list model is not the only class that can be used for more specific cases. You also have, for example, QAbstract table model, QFile system model, QString list model, etc. So when you create your own application, open documentation and see what meets your needs the best. Okay, so let's create our list model and implement the create, read, update, and delete functionality in it. Firstly, add a QObject. Here, C++ class, go to QObject to your project, and let's name it contacts model. Let's create it, finish. And here we have it, CMake is loading, and I will right away change the class we're inheriting. Here I want to include QAbstract list model, and this I will say in a second what we'll do with it. Let's change the class we're inheriting to QAbstract list model, and also change it here in constructor, so you won't have any bugs later, and you don't forget about it. Okay, and I also right away want to make this class QML element, so we can instantiate it in QML. If you're not familiar with QML element macro and C++ and QML integration, I strongly suggest you to watch my video about it, because I made a tremendous video that fully covers integration of C++ and QML. So in the source file we replace it, this class in the constructor, and now you can right click on the inherited class and go to refactor inherit virtual functions of base class. Here you see the full list of methods we can override. The important thing is that you don't have to override every method. You need to do it only you need to do it with only the ones that you need for your purposes. So, for example, if you want to only displaying, then override only displaying classes and don't touch the others like for updating. And it works. It's like depending on what functionality you want to customly make in your list. So to start off and display some data, we need to implement row count. It's already selected as like some most basic one. Then data so you can get some data from our model, and role names. Let's search for role names. Okay, I just wrote it here. Role names. I can here it is on the bottom of QAbstract item model. Okay, and override add virtual. You can just leave it as the default, so it will be okay. We can remove comments because we'll later add new methods, and it is not necessary for now. Okay, so you see you have those definitions for your methods you have to implement, and okay, we have to store name and the email. So let's also make a structure that will contain those fields, because I want to make a list with the same data as like here. Okay, here I make a structure with the name and email with the QString class, and I also defined the enum here. And wait a second, and when we will implement data and role names, I will explain the point of using it and what is happening here, what Qt user role, why we should define it. Okay, we store a list. So internally in model, we should store some data. In our case, it's the list, so we can just make it like here with the structure contact. And I also have to include vector. Okay, and we can either use one of the containers that Qt provides us, or we can use STL, like I done it here. I will use STL because Qt containers are pretty much legacy. One of the worst parts of Qt containers is that they do not support move semantics. With HTML, we can be sure that it uses the most efficient ways of working with data, and it's already it always up to date with all updates and so on. So I prefer to use vector here. Okay, we started in a private member of our class. Now let's go to the source file, and we can implement everything. But first of all, I want to add some mock data. If you like, wait a second, let me copy, and here I will paste my mock data. Here I just give some data to my vector, some mock data that we will test our application with this data, and I just pass it in a constructor with those braces, so it will initialize structure. It's like one of the ways to construct structure in C++. Okay, and if you don't know what is QString literal and why am I using it, then I strongly suggest you to watch my video about it. I explain it well when to use QString literal, when other classes related to string, and so on. And in the real world scenario, you'll most likely create a separate class to work with database and call some method from it in a container. But here we can just hard code some data to have an example. So if you remember from presentation, you have this like model and it pointing also to the data. And this data can be like separated class where you call your API, database, or whatever. Okay, so now let's go and implement our method definition for the row count, for the data refactor, and then the definition, just to simplify what we are doing here. Okay, row count simply returns the number of elements the view has to display. I earlier said that the QModel index represents row and column. In this case, method receives a parent index. We can use it in case we have a nested structure and want to give the size of the current node. I also add the Qdebug to output some text in console, and just so you see when this method is really called by Qt, by list view. I also have to include it, I think. Include Qdebug. Fine. I just write some data that notifying that row count is called, count is called, and return the size of my vector. Okay, role names. I will skip for now data. Okay, role names are an interesting one. We have to use a previously defined enum here. So let me copy and paste what is happening and explain you what is happening here. We have a hash table with the key of the enum and the value as the name of the property. Those names are going to be used inside QML. So like here, I use here name, email, and we define those strings with the roles. And here we specify it. So when you want to get a specific item in QML, you write a name of it. You write a name of property. But inside the C++ code, we can store it just as an integer, just as enum, to reduce the space that is used. The important thing to mention here is that Qt by default also have some roles. And I can show you by going to user role. Here you see we have some roles already. And because of that, our enum starts from user role. And then we continue this this list of enums because user role here is the last one. If we would normally leave it and start from 0, data won't be displayed because roles are conflicting with each other, and just no data will be displayed. By the way, I don't use QString literal here because the qbyte array and it is similar to QString, but it is not the same thing. This structure is used to store both row bytes and traditional 8-bit strings. Okay, and then I just return this hash table with all roles and the name of roles defined, specified. Okay, we have a data method left for us. This last method to implement for displaying. This method receives an index of the record and the role that we should return. The role is presenting a the role is representing a property of a structure. We store where we store the current record. So let me just paste the implementation, and you will see what I mean. Because and also QVariant is used to store reference to values where you don't know what type is lying inside. When you want to get the value, you should call one of the converting methods that will return stored value. So I don't know if it will be visible here, but if I write like this, you see you have so many methods like to chart, to day, time, double, and so on, so on. So you can just store a lot of primitive types inside QVariant. Because data method returns some properties. The property that the Qt is calling, that wants to get from us. And inside method, we are checking if index is valid, or more specifically, if the index is not going out of boundaries of our list. The thing is that Qt displays view so that it fetches only needed ones, only needed records, and then deletes them from the memory when the user doesn't see them. I will later make the list bigger, and you will see what I mean by looking at the console output. And I mean, sometimes Qt can provide not valid ID, so we have to check it here. And I return false if something is not right. Then I just qdebug something just so you see when Qt is calling our method, and then with the help of switch statement, I check what Qt asks for and return an according data. So here I just get the item that Qt calls us. I get row. I can also use column, but when you make your list, you just have to use one of it, either row or column. In my case, I will use row, and I return name if the role is name here. If role is email role, I return email. If none of them, then I just return false. Okay, and now let's create an instance of the model in main QML. It is quick and easy. And okay, so I can just write here contacts model unknown component, but if I okay, let's leave it as it is, because sometimes Qt okay, because I didn't import it. I have to import here when I use QML element. I also have to import this URI of my project and specify version. And now I will have it. I certainly will have it, okay? Let's move on quickly and also pass model in the list example, and we can also do it to the grid example just so you see that this class can be used in both cases. Let's delete from here model because we pass it from the main, and there is no sense to use it. And let's run application and check if it will finally work. Yes, as you see, it's just a problem of Qt Creator. And I made those Qdebug prints, and as you see, if we run the application, first of all, everything works. Data is displayed with the help of C++ model. But let's quickly, maybe let's comment also grid just to see what is written here to not get anything duplicated. Okay, so take a look. As you see, row count is called multiple times by the engine. And it is okay because we only return the size, and it's like so quick operation. Role names is called only once, and Qt stores that hash table in memory. Then data is called, let's count 1, 2, 3, 4, 5, no, sorry, 3. It's either wait, why it is interesting because it calls it 5 times. Okay, let's Control F. Oh, okay, six times. I don't know. Maybe I'm just blind. Okay, so it is calling data method 6 times. And this is exact number of data properties we have, because there are 3 elements, and each have each of the element has 2 fields here, name and email, and we have 3 like instances of contact. So we get data called 6 times. Just so you see how it renders when you have so many items, let's copy records in the constructor so many times and see the output. I will just copy and paste so many times the same record. So let's see what we have in our console in application output. Okay, so first it loads some data. And now as I scroll, it will load more data, because now not all data is loaded. Loaded is only data that Qt needs to show. And now if okay, I have some bug with list, but it don't really matter. Probably I forgot to add some parameter. And if you see, new calls to row count and data are generated here as I scroll. As you see, Qt is calling data and frees memory from the first elements. So Qt just used that way of displaying. That Qt loads only records that should be displayed at this exact moment. We have our displaying functionality, so now it is time to create new items in a list. Earlier we needed to override the data method, this one. Let me also hide the output. Earlier we needed to override data method from the QAbstract item model to display the data. When it comes to insertion, the abstract list abstract item model has base methods, but you don't really have to override them. So you have this insert rows and insert columns, but it is not like required to override them. You can create just a Q invocable method that receives whatever parameter you want and returns whatever value you want, but to get data updated in the GUI, you must call 2 specific functions from the QAbstract item model. Those are called begin insert rows and insert rows. I will show you now what are they and how to use them. And you should call them at the beginning and the end of insertion. And the same applies to columns. because here you also have insert columns. But in the list view, it only makes sense to change the number of rows. Okay, so even though I don't have to override a base method, I will do it, and I will also create my own method that will just call a base one with certain parameters to make the job easier in QML. So I just want to show you all ways to do it. Let's move it to all our methods, delete these comments. So here we have insert rows, and I will also create method that will be called from, that will be like manually called from QML. I will make this QInvocable. If you don't know what is QInvocable, go to the C++ with QML integration video, and let's implement them. So refactor, a definition as always. Here, this, sorry, here the same. Okay. Insert rows method returns a boolean value. And it returns it depending on the success of adding a new item. So if something is not right, something is failed, then false. It's everything is okay, then true, simply. And let me paste my implementation. Here we have it. Okay. On the first line, I'm making sure that the row and count are not negative. So here it's if it is less than 0 or count is less than 0, I return false, and everywhere I use or. Also, I make sure that the row where I have to insert new items is not bigger than vector size. I call here row count, but you could also call just items size. Doesn't really matter. And I check it because otherwise I can get some kind of gap in the data. So I can have like list, let's show it just with digits, like this list, and I should insert from like to 6 index, 6 row, and count 2. So I will have, okay, it is index 3, so I'll have like this gap. And to avoid it, I check it and return false if something like this is passed. After validation, I call begin insert rows method, where we have that method from Q abstract item model, as you see here, and I pass a parent index that always will be empty in our case because we don't have any sub-element system. Then row index where I start, and row index where I finish. And here I make some kind of calculations. So I give a row plus count because there is count of elements we will insert, because method is called insert rows, like many, and -1 because the list has zero-based indexing, and it also takes the last element into account. The actual insertion is probably the most understandable part of everything here for you, because I just make loop and insert a new empty contact instances to the vector. So here just call begin plus index where I want to insert. Just call in a standard method from STL. And after all insertions, I call end insert rows to notify Qt that view can be changed. So when we call it, the visual representation will be changed in some way, and I like update it. Okay, so here in the next method, append empty row is just adding a new item to the end using a previously defined method. I want to use all the power of insert rows and insert a lot of items at once, but I wanted to show you how to implement it. Yes, maybe you want it. Okay, and here I call row counts, and every time I provide some parameters. Maybe we can just make here default value to make our job easier and to not call it every time. Okay, fine. Now let's add an add button in our QML. It will just call this append the empty row method on click, nothing more. So let's go to the main. We can delete this grid and add button. Here also import Qt quick controls, because that is where button is laying. And on clicked, we just call context data append empty row. Let's start. Let's run and check if it works fine. Okay, let's add something, and we have our empty contact. We can add more and more. Okay, great. And now it comes to the most, I think, interesting part, updating data. Let's go to our class. So parent class QAbstract item model already has a method for changing data. We just have to override it. So it called set data here. Let's override, okay. And let's move it to our methods and add definition in source file. Similarly to the insertion, we have to return Boolean value that shows if an operation was successful. Okay, the method receives an index of the element you have to modify. In our case, we will only use a row, even though, as you already know, QModelList contains row and column. A value with the type QVariant that will be converted to a specific type depending on the role. That is a third parameter. So here you have my implementation. So firstly, I validate the index and create a reference to the item that should be modified. With the help of switch statement, I check what role should be modified, and if it is just some random int in the default case, then I just return false. As you see, I call value to string here and there, but the Q variant can, as I showed you before, Q variant can be converted to all kinds of primitive data types. So you can store in your structures integers, all kinds of numbers, dates, and so on, so on. Maybe some arrays. Okay, and finally, I not return anything like in create, like in data, sorry, like in data, because here I just return data that is requested. Here I modify data, then break this switch statement, and after that, finally, to notify Qt about data modification, I emit the data changed signal with the current index and role. Here I was index because if you take a look inside, it comes from the Q item model, and it also can work for the tables. So we have a top left and bottom right index we should pass, and the roles that was changed. In our case, only one role was changed, so I just create this Q list in this way with the initialization list, initializer list. Okay, and the QML part will be a little bit harder than before. It's not just adding a button now, because I want to replace the text item with the text field when a user clicks on a text, so he can edit it. So you will see now what I mean by that. It's just I found it like cool functionality. So let's add, okay, for now, don't add. Take a look here, because I will do it inside my delegate, and I will have to separate the text into three parts. First, it's like part with the name text that will be sometimes replaced with text field, and sometimes it's just text. Then this column sign, and then email. So it will be such a mess if I make everything in one document. So let me make, and this elements with name and email will be the same, pretty much the same implementation. So to not repeat the code, let me create a new document for it. And let's name it editable text. Here, let me pass some starting things. Here, I specify a required property, which is a field. The field that the item should work with. I add the text and text field that is coming from controls, and I put everything in row layout so it lays horizontally. Okay, and here I will switch visibility of those two items depending on if user clicks on it or no, if it's empty or not. And okay, the initial visibility is defined by whatever field is empty or no. So if it is empty, then I show text field and user have to write something inside. If it is if it have something inside, then user see text with this field. Okay. And to give the ability to click and edit, let's add a mouse over and slot in the text field. So let me show you how I done it. So here I just provide mouse area, and when I click it, I fill it with my name text, of course. And when I click on it, then name text becomes invisible, and edit field becomes visible, so user can write something, modify something. And when the user already modified something and want to like change it inside our model, there is that event called on editing finished. So either user presenter or something, then I assign this text from the text field to the field and change visibility one more time. And now when the input, when the field is empty, the text field is always shown, and set data method that we implemented earlier here, set data, will be called when is being called when I assign a field to the text input. So because here field I won't pass just some string, I will just pass this role from the model. Let me show you. Let's go to the list example, and you will see what I mean by that. So here I kind of rewrite this delegate, and okay, and I have to import Qt6 layouts. Maybe yes. Okay, so here I changed this delegate, rewrite it slightly. So here I have row layout, so everything lays horizontally. For now, it not really makes sense, but later I will add deletion functionality and I will add button here. And inside I make another row layout for everything also lays horizontally. And I make two editable text items. First with field name and second with email. And between them I make that column. And let's run it and see how it works. Let's add, and you see I can add something. If a field is empty, then it won't be changed to the just text because of where editable text, because of this if statement. But if I write something, don't know, email, doesn't matter, and press enter, then I have it, and I can modify it, change it. So in here also I can modify, change it. I can here modify, just you see how it works. I mean, I can modify and change the values. I can click and it is changed. Okay, fine. The way of deleting data is pretty similar to insertion, and we also can but don't have to define the remove rows method and call specific methods before and after the deletion. So it is pretty similar to insertion. Let's quickly do that and finish with our CRUD functionality. So go ahead, let's add implementation for remove rows. Move it a little bit higher. And I'll also, just as with the insertion, I'll add my method that will be just easier way to use this one. And parameters are similar to the same as in insert rows method. So it is obvious that we just have to remove the count items starting from the row index. Let's add implement as a definition and implement those functions. Yes, those methods. So here, I don't know if you see, because it's a pretty long line. Make it like this. Okay, so the implementation is pretty similar to the insertion, but like as previous, I validate indexes that were given to me, so nothing will crash with my STL when I call this arrays method. And just accept, and everything is the same except the thing that I call begin remove rows and end remove rows with the same indexes, and I call arrays instead of making some loop, because it still provides us a method where we can just remove from this to this, where we can provide the starting point and end point, and we can erase everything from vector. And inside the remove add, I can just write like this. I mean, I just call this remove rows method, starting with row that is provided to us, that I will provide from a QML, only one element, and empty Q model index, because we don't have any parents in our case. Let's go to the list example. And here inside the delegate, as I said you before, after row layout, I will add a button that will just call the remove add method and remove corresponding record. So here, except this stuff that you know, like passing text as minus, here I get this list because I have ID list in list view. Then I go to the model that is provided from main. Here we provide model, and then call remove add method, providing model row. Model row is just model. In our case, It's just the record. It is just a thing that is available to the delegate. We can get the record we're working with right now with the help of model, and I get row from it. The same, I can also get column if I want. So okay, let's run and see if it works. And we can remove, add, edit something, create whatever you want. Remove, add, remove. Maybe let's add many items, and just this way. And that is how we done CRUD operations in Qt, in Qt Quick with C++ model. I hope you enjoyed. I hope you, first of all, learned something from this episode because it was pretty long. I'm pretty tired right now, and also feel free to write your feedback in the comments. And see you later.